Hello and welcome to 9.6 Solving Rational Equations. We are first going to start off by one method of solving. We'll talk about a couple. So to solve, multiplying both sides of the equation to get the LCD, which is least common denominator of the terms. Simplify and solve the resulting polynomial equation. Okay, so this is just a simple set of notes for you. Okay, so this method is best used when you have more than one term on one or more sides of the equation. So, for example, looking at number 1, we can use this method because we have two terms on the left side and one term on the right side. So, to do this, we need to figure out what our least common denominator is. So if we're looking, what's the least common denominator of 3, 6, and 4? Well, our least common denominator is 12. So then that means we're going to have to multiply our first factor to try to get 12 in our denominator. So we would multiply it by 4 over 4. And then the second factor, what would we have to multiply to get 12 in our denominator? Well, that's 2 on top and on bottom. And then the last one, we'd have to multiply by 3. Okay, so when we simplify this, we end up getting 4x over 12 plus 2x over 12 equal to 24 over 12. Okay, so looking at this, since we have the same denominator for each, we can just eliminate those and we can ignore the 12s underneath and just focus on our numerators. So that would give us 4x plus 2x equal to 24. Combine our like terms, so we have 6x equals 24. And divide both sides by 6, so we get x as 4. Okay, and what's important about this is every single time we have to check our answer. Okay, so over to the right here, I'm going to check every single time you need to do this. So you're plugging our x back into our original equation. So we'll have 4/3 plus 4/6 equal to 8 over 4. We can put this in our calculator if we want to, just to make it easier, but we know the right side simplifies to 2. If we do put this in our calculator, we add it up, we should get that equal to 2, and 2 does equal 2, so this answer works. So our answer is x equals 4. Now sometimes when we do this and we check our answer, it won't work. So that's why every time we have to make sure that we check our answer. Alright, so that's our first method, using our least common denominator. Another way that you can solve is by cross-multiplying. Okay, so you should be familiar with this. So this method is best used when you have one fraction on each side of the equation. So looking at this, we don't have one fraction on each side of the equation, but we can easily get it to that point. So to do that, we can move the 4 to the other side. So that would give us 8 over x plus 2 equal to 1. And as we know, if we have any whole number, we can write that as a fraction by just putting a 1 in the denominator, and that's still the same number. So then from here, we can cross multiply. So that's multiplying the numerator of the left side to the denominator of the right side, and then the denominator of the left side to the numerator of the right side. So our 8 times 1, we'll put that on the left side here. So 8 equals, and we have x plus 2, and that's multiplied by 1, so it's itself again. So then from here, we would subtract both sides of 2, and so we get 6 equals x. Okay, so just like we did before, we need to check to make sure our answer works. So we're taking 6 and we're plugging it back into our original equation. So we get 8 over 6 plus 2 plus 4 equals 5. When we simplify this, we get 8 over 6 plus 2, which is 8. So that's 1 plus 4 equal to 5, and 5 does in fact equal 5, so we are good to go. So x equaling 6, I'm just going to rewrite it so x is first. That answer works, so that is our final answer. You need to flip the page over, and using these next couple problems, you can use whichever method you like better, but one method will be easier than the other depending on the setup. And either way, you have to check for extraneous solutions. So that's what I was talking about before. On our first page, we always have to check to make sure our solutions work, because sometimes we may get an answer that won't work. Okay, so let's try number 3 together. So, looking at this, we have a fraction on one side and a fraction on the other. So based off of this, I would say that cross multiplying is the easiest method. Now you could try to get common denominators here and ignore the bottoms, but cross multiplying is your best bet. So from here, you multiply 2 times x minus 1, set that equal to 1 times x squared minus x. So you distribute your 2 to give you 2x minus 2, and then 1 times x squared minus x is just x squared minus x. So let's get everything out of one side. I'm going to subtract my 2x, subtract 2x, and I'm going to add 2, add 2. So I have 0 equals x squared minus 3x plus 2. So here we have to say, well, can I factor? And I can. X minus 2, x minus 1, that equals 0. So then I should get an answer of x equals 2 and x equals 1. So then from here we have to check our answer. Remember, every time we need to check. So we're looking at our original equation. So we have 2 over 2 squared, which is 4, minus 2 equals 1 over 2 minus 1. Just plugging in 2 for x. So that will give us 2 over 2 equals 1 over 1. So 1 does equal 1, so 2 works. So we know that for sure. Now let's try our x equals 1. So I'm going to plug 1 in everywhere I see an x in my original equation. So I'm actually going to move this real quick. Okay. So we have 2 over 1 squared is 1 minus 1, and that will equal 1 over 1 minus 1. So that gives us 2 over 0 equals 1 over 0. Looking at this, we have a 0 in our denominator. That means that this solution is undefined. So this is not a real answer. So this x equals 1, that is an extraneous solution, so our only answer is x equals 2. Whenever we get a 0 in the denominator, that's a red flag to us that that is not a real number. So we cannot use that in our or as an answer. Okay, so now looking at 4, we have a fraction on one side and a fraction on the other, and then a whole number here. Now, you have your choice, whichever one you want to use, whichever method, the least common denominator or the cross multiplying. I am going to get a least common denominator here because I noticed something about my term, or this fraction here. This x squared minus 1, that can be factored to x plus 1 and x minus 1. So then, looking at my other term, this one here, all I have to do to get a least common denominator is multiply the top and bottom by x minus 1. So that is what I'm going to do. And then the 3, you can just multiply it by your x plus 1, x minus 1, which is the same thing as x squared minus 1. And remember, we have to multiply the bottom by x squared minus 1 as well. The denominator is just 1 here. Okay, so when we do that, I'm going to put parentheses around here. Okay, so when we're looking at this, we can FOIL this top part. I'll write it out all here first so we don't lose track of what we're doing. So we have x minus 1 times 4x plus 1, and that is equal to 12 plus 3 times x squared minus 1. And remember, we don't have to do anything with the denominators because they're all the same, or they all should be anyway. So from here, we need to FOIL this. So first numbers, 4x squared. Outer numbers, plus x. Inner numbers, negative 4x. Last numbers, negative 1. Equal to 12 plus, and distribute our 3. 3x squared minus 3. And then we need to combine our like terms. I'm going to get all my x squareds on the other side. So subtract my 3x squared, subtract 3x squared, and okay. It's not wanting me. Okay, here we go. So I have an x squared over here. I'm going to combine my like terms. So I'll have a negative 3x minus 1 equals 12 and negative 3. That's a positive 9. So I'm going to get my 9 on the other side. So subtract 9, subtract 9. So I'm left with x squared minus 3x minus 10 equals 0. So from here I can factor, and this factors to x plus 5 and x minus 2 equal to 0. So that gives us an answer of x equals 5 and negative 5. And x equals 2. Now, as always, we need to check. So let's check our answer. So we got x is negative 5. Let's plug that in. We plug in negative 5. We get a negative 20. Oh, just kidding. I realized I switched these around. That should be a negative 5 and a positive 2. Silly me, so I did have it right here. So that should be 5 and a negative 2. So when we plug this in, we should get 20 plus 1 all over 5 plus 1, which is 6, equal to 12 over 5 squared, which is 25, minus 1, so 24 plus 3. When we simplify that, it comes to 21 divided by 6 equals 12 over 24 is 1/2 plus 3. And this 21 over 6, that actually simplifies to 7 over 2. So 7/2, well, that's 3.5. So if you look, 3.5 equals 3.5. So we're good. Our answer of 5 works. So now let's test our answer of negative 2. So when we plug that in, we get a negative 8 plus 1. So that's a negative 7. And then we get negative 2 plus 1, so it's negative 1. And that equals 12 over negative 2 squared. So that's positive 4 minus 1. So 3 plus 3. And 12 divided by 3, that is 4. So when we simplify this, negative 7 divided by negative 1 is just 7. Set that equal to 4 plus 3, which is 7. So they both work. Awesome. Now, looking at this last problem, I want you to try this on your own, hit pause, and then we'll go over it together. And don't forget to check your work. Alrighty, so this is what we should have. Okay, so I decided to multiply top and bottom by x plus 1 for my 4 here, so I got common denominators, did my GCF. So we don't have to look at the bottom, and we just consider our numerators. So when we simplify, we get x equals negative 1. But when we check our answer, we end up getting 0 in our denominator, so our answer is undefined.